Okay, great. Thank you so much, Jacob, for organizing these. It's a poor substitute for being in a room with lots of you, but it will have to do, and it's lovely to be here. It's a great thing to be happening. I should also maybe say that one of the reasons it's regretful I'm not in a room with you is I'd love to be a few thousand miles away from my small children, and I'm not, and it's bedtime. So there's a small chance we'll recreate that glorious BBC video, except I'll lose my cool much more than the guy with small children who ran in, so apologies in advance if that happens. Okay, so what I want to talk about today, no surprise to any of you who know me, I suspect, is spacetime functionalism. Now, my aim for this talk, let's see. My aim for this talk is to give a little bit of an overview. I think literature on spacetime functionalism in the last few years, people coming at it from quite a few different angles, and in particular, people thinking about spacetime functionalism and how it might help us think about quantum gravity. Perhaps on a theme with Alyssa's talk, I'm not going to be terribly bullish on the opportunities to do amazing things for quantum gravity here. It'll be a bit deflationary. But I think that you'll be hearing this phrase bandied around in the philosophy of spacetime literature, and it'll be really helpful just to try and get clear on exactly what one might mean by spacetime functionalism and what it might do for us. So what I want to do in this talk is just to explain to you what I take the position spacetime functionalism to entail, I think what it has to entail, and then provide my preferred version of it, a kind of brief defense of what I call inertial frame functionalism. And I'll say a little bit about how the project might and might not help us to understand spacetime emergence, and hope that sort of links up a little bit with what's being talked about in the other talks. Okay, so what is this position spacetime functionalism? Well, the idea is just that spacetime is a functional concept. That is, a field or object is spatiotemporal by virtue of playing a certain kind of role in our theory. It's spacetime by virtue of what it does, not what it is. That's the kind of slogan. Now, functionalism, of course, has a really long history in philosophy. So the first part of my talk is going to be just trying to pick out the kind of functionalism we mean. And there's been some really helpful recent literature on this that I'll be appealing to. And then, as I said, I'll introduce my kind of functionalism. And one counterexample I think I can deal with helps show why it's useful, and go on to talk about a bit about emergence. So quite a long time ago, when I started thinking that something like spacetime functionalism might be a helpful way to think about spacetime, and in particular, I was thinking about something like Harvey Brown's dynamical view and how that might be extended, and how one might articulate a kind of version of that view. And I thought that functionalist thinking was helpful to that. I started my project by trying to ingest the literature and philosophy of mind on functionalism. And I got myself hopelessly confused. And I think that there's a sort of danger that others in the philosophy of physics will follow my footsteps. So perhaps, there are certainly people more able than me in the philosophy of mind. But within philosophy, the position functionalism comes in a lot of guises. And there are lots of labels for different forms of functionalism. And I think many of those are not coherently applicable to spacetime. In fact, I think many of those are not coherently applicable to anything. But in particular to spacetime. And so there's a kind of danger that I think some people in this literature are saying, well, I'm just neutral on what kind of functionalism we're doing. And then the project is not at all clear what you intend to do with the project. So I think it's worth saying exactly what we mean. So I'm going to take spacetime functionalism to be a form of realizer functionalism about the spacetime concept. There's a lovely, extremely recent paper by Jeremy Butterfield and Enrique Gnomes, who I don't know if it's in the public domain yet, but who just do a really nice taking back of what spacetime functionalism might be, and reminding us about kind of Lewisian roots of functionalism. And I think that the project, as I conceive it, is very much in the tradition of Lewisian functionalist reduction. It's something that those of us who have a bit of metaphysics training probably do understand, but it's not something terribly Mysterian. It also essentially needs to be functionalism about concepts. That's very important, rather than something perhaps more metaphysically loaded. But there is something funny about spacetime functionalism. So in a sense, Lewisian functionalist reduction, which I'll say more about in a minute, makes sense sort of for any theoretical concept, but is trivial for a great many of them. But it's not perhaps trivial for more experiential concepts. And space-time sits at a kind of funny boundary between the two things. And there's a question about what one's doing when one applies functionalism to the concept of space-time. And I think that's a tension. So there's a recent paper by David Chalmers that talks about the relationship between his spatial functionalism and space-time functionalism. And he has a nice little metaphor. So I'm just going to copy his metaphor and introduce it to you and modify it a little bit, because I think it's a nice way of trying to understand what we might be doing and why it might or might not be interesting in the case of space-time. Okay, so Chalmers' story is the following. He gives you this metaphor for thinking about how he reconciled the manifest and scientific images, right? So he says, look, in the Garden of Eden, things are exactly as they appear. Objects have colors in just the sense they appear to. You know, there's really surfaces that are really green in some solid green sense that is the kind that we experience. And then, of course, a little bit of science comes in, and we fall from Eden, and color primitivism no longer seems to be an option. And a very natural response at that point is to develop functionalism about the concept of color. You say, look, there's nothing in the world like my Edenic conception of color, but colors are whatever is responsible for our color experience. So whatever plays the functional role of color just is color. And now I'm going to go out and do a kind of scientific investigation to work out exactly what color is. That's kind of realizer functionalism. It doesn't need to imply anything fancy metaphysically about colors. They can still be physical properties. You know, whatever we decide, if you decide that it's, you know, the propensity to reflect certain kinds of lights in certain ways, that's what color turns out to be. So it's not a kind of particularly fancy metaphysical view, and it's a very natural view when you're thinking about the ways in which the properties of our experience don't quite match the properties that science hands us back. Here's a non-Chalmersy, less poetic way to put it, which has more in common with the way that Butterfield and Gomes talk about it. We often functionalize a concept when we realize the concept is problematic from the perspective of our current science, right? So that allows you to reduce a problematic concept to a scientifically acceptable one. And so one use of functionless reduction is you have some tricky concept in one theory or one level of discourse, and by giving it a functional analysis, you can reduce it. You can find the thing that fulfills the role in some other theory, in some unproblematic discourse. Of course, not all functionalism is functionalist reduction, right? Some concepts are just obviously functional and unproblematic from the start. So I take it the concept of corkscrew is a little bit like that. And one of, I think, the tensions in this whole debate is nobody can work out whether it's kind of obviously wrong or obviously right, because there's no community conclusion about whether space-time is more like colors or space-time is more like corkscrews. And if you're following me at all, I suspect about half of you think it's like colors, and about half of you think it's like corkscrews. That's how things tend to go. I don't know which way this particular audience skews. Okay, so before we get on to space-time, let's talk about Chalmers' spatial functionalism, because again, this kind of starts to move us towards space-time, but it still works for this kind of Chalmers story, right? Our Edenic conception of space is that of a perfectly living container. You know, your notion of it's like the space of the room that I move around in. Chalmers thinks that becomes problematic with the advent of relativity and quantum mechanics. I think the fall from Edenic space happened earlier. I think it happened with Galileo. I think that it's really easy once you've done a bit of physics, right, to underestimate how deep and startling the relativity principle is to people's totally intuitive conceptions of space. I mean, you know, most of our students will have encountered enough of the relativity principle that they can kind of understand that there isn't a preferred reference frame. But our intuitions about space very much come from the notion of a preferred reference frame. So I think that quite early on, you have this kind of clash between the scientific image and our notion of space. And Edenic space gets replaced by the notion of a reference frame, which is a highly functionalized and operationalized idea. Think about the role that Galileo's ship plays in Galileo's thinking. And then I think Chalmers is exactly right. So David Chalmers has this project of spatial and temporal functionalism, saying, look, Edenic space and time are problematic, and you need to recover them, the experience of space and time, by a functionalist story. And that looks very analogous to color. But space-time's a bit different. Space-time isn't space or time. My 5-year-old daughter does not have an Edenic concept of space-time, and arguably she does have some concepts of space, right? So, so space-time is slightly different. It's not space. But I think one thing that happens very naturally in philosophy is that we are tempted to import Edenic spatial notions into the space-time context. So there's a certain kind of substantivalism that sees space-time as something like a container, a stage, or an arena. And I think that that's very much taking that already Edenic conception of space, right? You know, it's not right about space either, and putting it onto the space-time context. And of course, the way that we teach general relativity or we popularize it doesn't particularly help. Rubber sheet analogies, geometrical analogies with spatial geometries encourage that kind of importation. But we have even less handle on that Edenic space-time than we do on Edenic space. And of course, remember the whole story about an Edenic notion is that it doesn't exist anyway. We can't coherently kind of conceptualize it. And space-time actually, I mean, despite having the word space and time in it, right, it's also very much a theoretical term. It's not one that's based in our experience. And arguably, most all theoretical terms are already functional, you might think. So if you take that view, space-time functionalism is trivial. It's a theoretical term and it's going to have a functional analysis. If you do think there's an Edenic conception of space-time, I think you should think it should be replaced by functional analysis. So, I mean, in a sense, the lesson here is that we should all be just, or rather obviously, space-time functionalists. So why talk about it? I mean, if in a sense it's fairly obvious. Well, space-time is very particular. And so it might be more important to get the functional analysis of space-time right than it is for any arbitrary theoretical term. Or you might think that the business of philosophers of physics and interpolation of physics is doing this kind of analysis. But space-time is particularly interesting because it has a direct connection to operational procedures, right? One of the things you do with a space-time theory is you read off predictions from space-time structure in a way that's just not generally the case. If you think about what the actual direct measurable predictions are of many non-space-time theory, they come down to measurements of distances and times. And this is, of course, the reason why the position basis is useful in quantum mechanics, right? So getting the space-time structure of a theory seems fairly right for interpreting and thinking about its empirical significance. And that's one reason why people have sort of argued about emergent spacetimes and space-time functionalism. You might also be interested in identifying space-time in theories that have no direct operational significance, and you can carry over the same kind of functional principles into those. The question about whether what you're doing there is just some kind of linguistic project or it's metaphysically meaningful is going to be one that's a matter of taste. But I mean, even the most kind of, you know, is important. Okay. Telling me my internet connection is unstable, which is very annoying. So someone shout at me if I've frozen and no one can see me. Again, on the topic of what on earth are we doing? I suppose it might be tempting to look at this project if I'm giving kind of a one true analysis of the space-time concept, and you think, well, goodness, well, has you read any history of science? I'm a terrible historian, but I mean, surely, if you think about things a little bit, you realize there isn't one space-time concept. If you just think about the move from special relativity to general relativity, our space-time concept changes enormously. So it's sort of obvious that we shouldn't be seeking to analyze the one true space-time concept. Now, here's the point where I get a little bit regretful that I can't find a point on this from David Albert, because it'd be really nice if I had ABC on the slide. I should also say that I just thought there weren't enough pictures in my talk, and nothing about the pictures meant to imply, you know, that some philosophers are larger than others or more important. And you can read, if anyone knows comes back, you can read it either way. I mean, what's the problem? So anyway, and it's terrible to do jokes on Zoom. People don't laugh much at my talks anyway, but it's very hard to be honest. Okay, so David Baker, who I think, I mean, there's a remarkable number of people here, but it's amazing that given the number of people who've criticized my views on space-time functionalism, that only a few of my critics are here, I think. But David Baker, in a paper about space-time functionalism, puts it that space-time deals with this problem, this shiftiness of content concepts, this fact that you can't just nail down one space-time concept by saying that space-time is a cluster concept. That could possibly come up with respect to space-time, and then you're just looking for something that fills most of those. So that's one way of dealing with a conceptual shiftiness. Another way of dealing with conceptual shiftiness is to do what David Chalmerism. There are lots of concepts in the close vicinity of any one that we pin down. Now, of course, you might have philosophical views that commit you to one or other of these kinds of views about concepts. I'm not sure I do outside of this particular context. So I'm going to plump for little cat C and conceptual pluralism here, just because I think at the end of the day, what I'm trying to do is something that might be useful for theory and interpretation. And I think it can be hugely useful, and hopefully I'll give at least one illustration that will show how this might be the case. I think it can be useful for theory interpretation to find a space-time concept, one that seems to apply to our existing theories, knowing that it's not the final word and that we might adjust it and there might be another concept in the vicinity that turns out to be more helpful, and apply it to some new theory that we need to interpret and try and work out whether you can import, say, our general relativistic conception of space-time into this new theory. And particularly if, say, you expect general relativity to sort of come out as true in the wash in some kind of sense, that might be what you're interested in. So I think that the cluster concept picture isn't terribly helpful for the interpretation of unfamiliar theories. You're just going to go, oh, look, this thing's a little bit like this, a little bit like that. But I think it's a little bit more helpful to adopt this kind of conceptual pluralism, whilst acknowledging that it's not the one true concept. Okay. So that's the kind of space-time functionalist project. And I think that if you stop there and you don't give an analysis of the actual space-time concept, you could very well just find saying, look, so what? I mean, there's a lot of literature on this at the moment, but you still might think, you know, why are you just talking about the space-time concept? I mean, for a sizable portion of the philosophy of physics community, I think space-time was already more corkscrew than color. It was sort of obviously functional. I haven't said anything that's particularly new. So merely asserting space-time functionalism, merely asserting that space-time is a functionalist notion isn't particularly interesting. But it might be much more interesting to spell out the relevant functional role. So a lot of my work is dedicated to that later project, spelling out the exact functionalist role. But I think just you need to get the background in before you work out what it's doing. So the kind of functionalism that I've advocated, I call inertial frame functionalism. So the idea here is that something is space-time just in case a structure is space-time just in case that structure defines the local structure of inertial frames in the theory. And you need a pretty rich notion of inertial frame for that to work. We could do lots of fiddling with the exact definition, but you don't want to rely solely on the notion that inertial frame is one in which a force-free body moves a straight line, or just on the notion of inertial or natural motion. What you want is a pretty rich notion that says, look, inertial frames, yes, are the ones that define force-free motion, but it's also the case that the laws of physics take a particularly simple form with respect to the coordinates of inertial frame. And it's also the case that all bodies in physical laws pick out the same equivalence class of inertial frames. That's going to get you back something like the notion of space-time that I think we have in general relativity. And I think it's going to do a reasonable job of saying something, sort of adjudicating on certain kinds of debates you might have elsewhere. Good. So why is that a useful notion? Well, I mean, the first thing to say is that obviously that notion of inertial frame is itself functionalist. And that's sort of exactly the point. You've not done a huge amount by moving from space-time to inertial frame, but I think what you've done is capture a lot of our intuitions about space-time in a notion that's kind of obviously functional. I assume nobody has an Edenic conception or a primitivist conception of an inertial frame. As I said before, that notion is very rich. So there's a huge class of counterexamples people give to this where they go, well, this isn't, this is a bit of space-time structure that doesn't involve inertial structure. And the answer is, well, actually, if you look at that definition, it covers a lot. So in particular, that particular notion of the structure of an inertial frame picks out both projective and conformal structure in a relativistic theory. So that's sort of one, I mean, I should say that, I mean, I'm sort of, in order not to bore people who aren't part of this debate, I'm not going to, I haven't sort of gone, there's a version of this talk that could be sort of ended back and forth with particular people. But I won't sort of cite all of them. But maybe two people worth mentioning, so David Chalmers and Michael Esfeld both think that that definition of inertial frame is illegitimate because it imports spatiotemporal notions. For Michael Esfeld, it's actually so deeper than that. It presupposes a certain kind of causal role he thinks that requires spatiotemporality to function. There's a lot more to be said about that, but I think that that can't be the right way to object. I mean, I think that, if you're familiar with functionalism and the philosophy of mind, right? Nobody thinks that the fact that the functional definition of the pain state involves other mental states is a reason that you can't define pain that way. And likewise, I think you can define the notion of inertial frame while simultaneously functionally defining associated concepts, right? I don't think that force free body and concept velocity presuppose space-time. They're interdefined on this definition with the notion of inertial frame and the notion of space-time. And that's a perfectly acceptable thing for a functionalist theory to do. If you wanted to go into the details of it, I think you can do some interesting examples. You can look at what it looks like if you look at a theory and all of its variables to try and define some structure of frames. I mean, you can think about doing this with a sort of fiber bundle or something. You think about why is it that some ways of coordinatizing a fiber bundle are special and other ways, if you're dealing with that larger space, are not. And it's non-trivial to find a structure in which the appropriate notion of, say, in space-time, force, straight line motion, and inertial frame are all realized. To find coordinates in which this is true on a general space. So I think that what one's asserting when one asserts this is that you have a space-time theory just when you have a kind of richly structured theory where certain kinds of functional concepts all interlock in the right way. Good. So, but I mean, the thing that's got me thinking about this kind of thing is actually just thinking about how to deal with sort of all things people said about physical theories. And so I think the utility of the inertial frame concept becomes most clear when you consider putative counterexamples, because I, of course, think I can deal with all my counterexamples. So whenever someone throws one at me, I think, actually, hang on, and that's kind of, yeah, that kind of makes me think that I'm onto the right thing. And one such example, I'll just do one, just because it's kind of a fun bit of philosophy of physics. So one such example was proposed by Dave Baker, who says that an orientation field, if it existed, would be a piece of space-time structure which would not meet the inertial functionalist definition. Now, perhaps I should note from the get-go that you might question what's going on here. We have instincts about what constitutes space-time structure, apparently. I mean, I kind of agree with David. The orientation field sounds spatiotemporal to me. But of course, if the counterexample game is just people saying, well, this seems like space-time structure to me, is it or isn't it by your lights? It's not quite clear exactly what the rules of the game are and why I can't just say, well, no, it's not. But I think maybe one thing that's interesting about this example is that my instincts are going to go along with Dave's, but I also think that this definition can handle it. And so I think one of the things that shows is that this particular functional definition of space-time accords with the kinds of instincts that make us call something a piece of space-time structure in the first place. Good. So an orientational field is something that induces a sense of handedness everywhere in space-time, right? It tells the difference between left-handed and right-handed objects. So an easy way to do that, you just represent a tetrad field over the manifold, which defines a preferred sense of handedness. And to most people, I think that looks kind of spatiotemporal, something that defines left from right, right? I agree with Dave that if we accept the reality of an orientation field, it should count as a piece of space-time structure. But I disagree that that's not accounted for by inertial frame functionalism. And in fact, I want to turn it on its head and say, look, it's kind of a nice example of exactly how tied up our notions of space-time are with preferred reference frames. Okay, so why would you introduce an orientation field in the first place? There's a lively debate in the literature over the right response to parity violating features of the standard model. Right? It's probably familiar ground for people. But again, it's one of these kind of a classic little bit of philosophy of physics I'm about to go into. So, so of course, the weak interaction, right, isn't preserved under parity transformations, right? So it's so if you have an experiment like this one where you have beta ray emission from a cobalt nucleus, if you mirror the whole thing, you just flip it in a mirror, you don't get the same picture. You have the beta emission coming out in a particular handedness with respect to the rotation of the solenoid. Right, so that's just one example of the ways in which we have experimental violation of parity. And so you have certain phenomena, like the last one, and the physics which underpins them are not symmetric under parity transformations. If that's going to be the case, something has to determine which processes are left-handed and which are right-handed. So you just can't have this experimental difference between left-handed and right-handed processes. That's something explaining it. Handedness could, of course, just be determined by relation to other handed processes and objects. So it could be that, you know, the handedness is picked out by all of the different interacting systems. But there's a worry that that requires a kind of non-local determination of handedness. How does my, you know, cobalt experiment over here know what my cobalt experiment over here is doing? And so a local explanation, one that doesn't involve actual distance, requires the introduction of a local field that can distinguish between left and right. And that's all an orientation field does. Right? Just introduce a field that everywhere in space time tells you what left and right is. Now, the fact whether we should reify, and the point here is that's not a sophisticated argument. We could offer for it, we could give more reasons, or we could reject it. But leaving aside the question of whether we should accept the orientation field as physical, suppose you've decided it is. Does it count as a piece of space-time structure? Of course, I mean, there's nothing drastic experimental that's going to hinge on this particular debate, but I think there might be, in sort of more far-flung theories, we might find ways in which these kinds of adjudications matter. So for the inertial frame functionalist, right, that's going to depend on whether the orientation field plays a role in defining the structure of inertial frames. Now, no one thinks an orientation field is all a space-time structure, right? It doesn't completely characterize the structure. But in a parity violating universe, it might, alongside the metric connection, play a role in determining inertial structure and therefore count as a piece of space-time structure. So that's the question on the table. And I think the answer is rather obviously yes. Right? If you want to see the orientation fields, if you decide to postulate them, you just have to think about the physics that underpins the parity violating weak interaction. Right? So the preferential handedness that you see in those experiments is just a consequence of the fact that only left-handed components of a Dirac field couple to W bosons. And that just comes about because laws governing electroweak interactions in the standard model distinguish between left and right components of such a field. But the relevant sense of left and right-handedness here is referred to this handedness of a standard Cartesian coordinate system, right? And so when you write down the laws underpinning the interaction, they take a uniform form in the right-handed coordinates associated with a particular class of inertial frames, a normal set of right-handed coordinates. If you fix the form of the laws, you pick out a set of inertial frames of a particular handedness in which the laws take that particular form. But obviously, lots of questions here. I'll get to those in a second. The function of an orientation field is exactly to pick out a preferred handed class of tetrad or frame fields and their associated coordinates. So exactly what an orientation field does is basically pick out, you know, just the right-handed inertial frames, functionally, if you think that inertial frames are well represented by, say, tetrad fields. Maybe it's worth going into in a tiny bit more detail. There's a nice, I mean, of course, all I'm doing is piggybacking on a debate about the reality of orientation fields. And there's a nice paper by Oliver Cooley from 2003 on this. So if you want to see that a little bit more historically, just look at how you standardly write down, right, the left and right-handed components of Dirac field in terms of gamma matrices. And if you want to change the handedness of a coordinate system, you just swap the labels on the coordinates x1 and x2, right? And so you swap the gamma 1 and gamma 2. And that just changes the sign of the gamma 5 matrix that appears in the left and right-handed components. And it just exchanges your equations for the left-handed and the right-handed components of the field. So what does that mean? Well, it means that, I mean, obviously in a pretty minor sense, but the form of the laws involving the left and right components of the Dirac field are not invariant under a change of handedness of some class of inertial coordinates. If you change the handedness of your coordinates, then you change the form of the laws. So if you think that inertial frames are a set where which effectively respect the symmetries of the laws, right, where the laws take the same form in all inertial frames, they don't, strictly speaking, take the same form in the left and the right handed coordinates. Of course, this isn't as simple as sort of, writing down your field equations of some other theory in an obviously non-inertial coordinate system. There's something a little bit tricksy about all of this. When we changed the handedness of our preferred coordinate systems, we arrived at a different, but completely equally empirically adequate form of the laws. It was just as simple. In fact, it looked remarkably similar. In terms of the orientation field, that corresponds to the fact that you could either write down the laws relative to an orientation field for which parts of the Dirac field congruent to the orientation field coupled to the W boson, or you could write them down relative to an orientation field for which parts of the Dirac field incongruent to the orientation field coupled to the W boson. So if you decide to introduce an orientation field, it will be underdetermined what orientation field you introduce. Those two formulations will be empirically indistinguishable. So that's one of the reasons why orientation fields are icky, right? I mean, it's not kind of, feels like a slightly ad hoc and very undetermined bit of structure. But is that a problem for the notion of inertial frame functionalism? I think no, right? If you think that kind of underdetermination is a problem, you should just reject the orientational field to begin with. But the question we were asking ourselves, weren't our orientation fields real? It was, these things seem more spatiotemporal. Have we not captured our notion of spatiotemporality with this definition? But if you accept the existence of an orientation field, it counts as a piece of space-time structure by virtue of picking out for a class of frames. In a sense, I think that's sort of how I want to use the functionalist view. So it's one thing I think that is useful to do in certain kinds of debates in space-time theories is to separate the question of what's space-time from which mathematical objects we take to kind of represent some kind of real object. So you sort of ask about the ontology of the theory first and which bits represent space-time second. And that's sort of exactly what you're doing here. So Baker kind of acknowledges that this could happen, that you could think of the orientation field as either picking out the right-handed frames or the left-handed frames as inertial structure. But he has two objections. He says, look, inertial frame functionalism can't pick out either the left-handed frames or the right-handed frames as inertial structure. It's only determined once we can choose conventional form of the laws. And his other objection is that the symmetry group of the non-weak interactions is still the Poincare group. So they seem to pick out different inertial structure. I mean, look, on one, totally granted symmetry and handedness are tricky. It certainly seems attractive to me to see two representations with laws differently defined with respect to that field as representing one and the same situation. And that might cut against reifying the orientation field. But that can't alter the clarity of the functionalist verdict. Once you decide that field exists and someone tells me, God comes down and says there's an orientation field in your ontology, then it picks out a handed class of inertial frames relative to a conventional choice of the form of the laws. Again, it's obviously where you put your minus and plus signs is going to be to some degree conventional, but that doesn't mean that there isn't a difference in the form of the laws if you change your handedness. On Baker's second objection, that some laws have a wider symmetry group than others, I think that's no objection at all. I mean, the point of inertial structure is that all of the laws take a uniform form with respect to those frames. And if some laws have wider symmetry groups, then, I mean, if you lived in a world without the weak interaction, you would have a wider class of inertial frames. But of course, the very reason that we are inclined to think the orientation field would be a piece of space-time structure if it existed is that we have a dynamical asymmetry, which seems to require spatiotemporal asymmetry in order to explain it. The tie between dynamical symmetries and space-time symmetries goes very deep, right? And I think that's exactly the reason we're inclined to call the orientation field a piece of space-time structure. So if we exclude the weak interaction, then you'd have a wider class of inertial frames and less space-time structure. But I think that's absolutely fine. Good. So that's kind of my pitch for inertial frame functionalism. It just sort of, it accords well with our intuitions. And I think, I mean, I don't know if that's a useful application, right? Because I don't know that deciding whether an orientation field is space-time structure is crucial. But I think that there are some other cases of novel theories or theories with sort of dubious interpretations where it can be enormously helpful. Okay, so on to my sort of slightly, well, it's not disconnected, but my final sort of section on emergent space-time. So I think that this kind of functionalism is going to be useful in part because sometimes you're going to look at new theories and you're going to want to understand what their empirical content is. And one question you could very much ask yourself is, can I find something like space-time structure that would have the requisite empirical associations with it? And inertial frames might be one guide to whether you can find that kind of structure. But there's another claim that's been made for space-time functionalism. It's that it's going to kind of allow us to see how space-time emerges from a non-spatiotemporal theory of quantum gravity. So you get this claim that some, or maybe even all, current theories of quantum gravity lack space-time at the fundamental level. Depends what you think about the kind of base spaces of various kind of versions of quantum gravity. And certainly it's a popular thing to say, right, that we're going to need to understand space-time of, say, general relativity or of our own experience, one in which we do experiments, as non-fundamental and perhaps emergent. Now, of course, it's really important that we don't mean anything terribly strong by emergence here. We almost mean weak emergence, perhaps very weak emergence, influence novel and robust behavior that could be compatible with reduction. So emergent space-time, you know, isn't quite as sexy as it sounds. But the thought is that there's going to be a puzzle here because you're going to have a fundamental theory that looks like it doesn't have space-time in it. And we still need to get back to the world that we actually live in. And the thought is functionalism is going to help with that. And you might think that's doubly puzzling because the kind of functionalism discussed here is usually talked about in the context of reduction. So there's this thing, you know, Lewisian functionless reduction. You use functionalism, right? Remember, to take a problematic concept in one domain of discourse and reduce it to unproblematic concepts in another domain of discourse. So why should we think that space-time functionalism has anything to offer the study of emergent space-time? Well, look, I mean, I think it does offer something. I think we know that our world contains space-time and something realizes that role. And then we therefore know that if a quantum gravity theory accurately describes our world, it must contain or at least reduce a theory that contains space-time. But we have this puzzle about what should we then say about space-time within quantum gravity? How can we claim that there are quantum gravitational theories without space-time? And there are some authors that think we just can't. I mean, I think I'm fairly sympathetic to some people who think that there's a sense in which space-time functionalism tells you there is space-time in theories of quantum gravity. Right? It tells you something will realize the space-time role in the world that we live. We know that as a fact. But I think we could consider two very different kinds of case, and space-time functionalism can deal with either one of them, and perhaps gets rid of some instincts that we might have that make some of these things look particularly tricky. So contrast the following two cases. There's one kind of case that you can have where some theory of quantum gravity directly picks out a structure that fills the space-time role. So I think there's a nice little example of this in a case of non-commutative quantum gravity and a particular version of it. And you get the non-commutative dynamics directly picking out the general relativistic structure of inertial frames. And so there, space-time functionalism gives you the perhaps, I think, slightly surprising verdict that a theory of non-commutative quantum gravity that looks, you know, rather non-spatiotemporal does in fact have a rather nice realizer of the space-time role within it. And you can contrast that with, say, what we might consider to be the more obvious case and what you might expect to come out of something like loop quantum gravity, right? A theory in which the geometric is going to be recovered by taking some kind of, say, continuum limit of a discrete structure, or by thinking about certain superpositions of certain kinds of states or something like that, where you might have a route from the fundamental variables of your quantum gravity theory to general relativity that involves some things that we think of as hallmarks of emergent theories, just as you might take thermodynamic variables to be emergent from fundamental particle physics. So both of these cases, I think, a space-time functionalist can talk about. On one, you might think there's no emergence, and on the other, you might think there is. So again, space-time function is not going to adjudicate, but it's going to at least accommodate both of them. So the advantage, on my view, with space-time functions is precisely not that it magically gives you space-time emergence. It's precisely that it doesn't tell you whether space-time is the kind of thing that's emergent. So you might think that it's a traditional, this conception of space-time, I don't really think we have, but this sort of container, Edenic conception of space-time seems prima facie incompatible with the emergence of space-time. But functional notions aren't incompatible with emergent notions at all. There's nothing in the functionalist definition that says that the realizer of a functional role has to be fundamental. The realizer of a functional role can be all sorts of complicated things. If your other views on intertheoretic relations, emergence, metaphysics, etc., mean that you're happy to reify non-fundamental entities, it's going to make perfect sense to say that whatever plays a space-time role in a theory is rightly thought of as an emergent or non-fundamental structure entity, and hence that space-time is emergent or non-fundamental. You can't skip that step. You don't get emergence from space-time functionalism. But if you already have a theory of emergence you like, you can accept an emergent entity as space-time perfectly well in the functionalist definition. Whereas if you think space-time is a fundamental container, perhaps dead in the water. But the important thing is on that view, and I do think that this is something that some of the literature kind of needs to acknowledge, space-time functionalism allows for emergent space-time rather than mandates or explains it. Where the real work is going to be is in saying that, in claiming that a piece of space-time structure in a given theory is emergent, you're going to have to give an account of emergence and establish that the space-time structure identified is emergent given that account. So I think a lot of the work is actually somewhere else than that some of the space-time functionalism literature is placing it. Good, so that brings me to the end. Space-time functionalism, best thought of as realizer functionalism, space-time concept of a reasonably familiar stripe. Nevertheless, lots of useful work to be done in articulating the space-time role, and I like my version. And an analysis like this allows for the emergence of space-time, but doesn't explain it. Thank you very much.
Thanks so much, Eleanor. So it's 1:45, so we have about 10 minutes for questions right now. I'm going to ask people who want to ask questions again to click on the hand raising tool in the participants window, and I'll call on people in order. I think it makes sense to call on Dave first. Dave, why don't you go for it?
Thanks. Yeah. So, I mean, well, look, as you would expect, I don't agree with your objections to me, but like, I don't think I would say anything beyond reiterating what I say in my paper. So like, whatever. I want to say something though, to kind of push the Esfeld line a bit more, which I also kind of agree with as potentially a problem for your view. I mean, so like, clearly to go with your analogy, it's clearly legitimate to give a functional definition of pain that, like, for example, appeals to the concept of desire, right? And like wanting to avoid something or something. What would be a mistake and like kind of problematic would be, for example, to give a definition of pain that appeals to the concept of chronic pain. And you might think that what you're doing is a little closer to the latter, since force-free velocity, things like this, you know, are kind of subsistent on spatiotemporal properties in much like the way that chronic pain is subsistent on concepts of like pain properties. So I guess I wonder if you could say more about like why you think that's not what's going on here.
Yeah, so I mean, I actually think that the notion of, say, a force-free body or a straight line, straight line's probably trickier. Constant velocity, I think those are much more like, you know, anger, desire, whatever you take it to be, in that they're interdefined with space-time. But I don't think that they're, I mean, I think, I haven't seen an argument, I don't understand the idea that a force-free body is a notion that is, I mean, constituted by space-time, a subclass of space-time in the way that chronic pain would be. It doesn't seem to go through, right? The point is that you can't know, you can only pick out the class of force-free bodies once you know something about spatiotemporal structure. You might only be able to know something about spatiotemporal structure once you know what the class of force-free bodies are. And there's a complicated story about how you epistemically come to understand that. But I think those two things are functionally interdependently defined. You know, if you think about just Newtonian mechanics, right? If you think about the way in which you might think about the Newton's second laws as posing some circularity, and then you think of it as reaching mutual interdefinition. I think that scenario is pretty much exactly the one that you have in a mental functionalist space. So I don't think, it's not that when I think that the chronic pain analogy would be more like if I was trying to define, you know, regions of space time in terms of space time, or I don't know, sets of space times and some kind of interdependent functional definitions.
Yeah. Okay. I mean, I guess. Well, I'm a little more sympathetic to the idea that like it's parasitic, especially given that I think that like it's clear that you can have spatiotemporal structure without any notion of force, like in like what I think is happening at the fundamental level in Flash GRW, for example, where it's just like, you know, there's nothing moving. There's like teleporting or something going on, right? I don't know. I guess like I feel like that makes me sympathetic to the idea that, yeah, you know, there's a notion of going from one location to another, and then force gets defined in terms of that, right?
Yeah, I think the Flash GRW, I mean, I don't know enough about the dynamics of Flash GRW. I mean, obviously, there's some point at which you don't have continuous trajectories and forces, and that part of the definition is good. And then you do get into this kind of, conceptual shiftiness. I mean, it might well be that you have to move to an adjacent concept, but you do still have a form of the dynamics and a form of the laws, and you still have symmetries of those laws. And I think the question of what are the inertial frames is going to depend on what the symmetries of the set of the dynamics that you set up are. So it's not that, yeah, I mean, and of course, I mean, part of this does get into this kind of, you know, your and my intuitions trading off against each other, because, I mean, of course, you can sometimes, you can set up an example where you presuppose the existence of a space and you talk about particles jumping around in that space. But I mean, I suppose the essential question to me is, are there multiple ways to describe that scenario? I mean, you can set up some coordinatization according to which you've got particles jumping in one way, and another coordinatization according to which you've got particles jumping in another way. And the real question about is how do you write down the dynamics in those two systems, right? And until you've done that, I think you don't think you have any handle on what the inertial frames might be. And I think I really think that even if you don't like this version of space-time functionalism, the idea that you could work the space-time structure out of some kind of stochastic particle theory without looking at how the actual laws of physics work seems like not a view that anybody should be committed to.
Great, thanks, Steve. Next, I have Neil.
Hi. Yeah, this is a fairly short question. I mean, in some ways, yeah, kind of more clarificatory. So just kind of like so is there a difference between something being an inertial frame? Or is an inertial frame sort of the same thing as a class of privileged coordinate systems? Could I sort of just use those two terms interchangeably, or are those things you distinguish between? I mean, I was particularly thinking about the orientation case. I almost felt like I can see how the orientation is playing a role in picking out a class of preferred coordinate systems. It's less clear to me that I want to think of this as I don't know, as what I've been previously accustomed to think of as an inertial frame. But if I can be persuaded I should update how I think of that, then all to the good.
How do you think of an inertial frame? As a field?
Sorry, you broke up.
Do you think of it as a tetrad field, or do you think of it as? So I think the most natural counterpart to a reference frame, right, is a.
Right. So I guess, yeah, I mean, I
your
would,
associated coordinates, but sorry.
yeah, so I would almost think of an inertial frame or like a reference frame, yeah, as not including a choice of spatial coordinates, I guess. I mean, to some extent, I mean, the risk is that this just becomes terminological, but yeah, I don't know. So if I take Newtonian mechanics, say, and I'm doing it with a, I mean, to some extent, I guess, like a Newtonian spacetime, I would sort of think of as having the structure of that's picking out an inertial frame, even if I'm using, so I can use kind of 3 vectors and stuff. So I'm not committing to any coordinate system on the specific spatial slices, but because I've chosen a standard of rest, that's a sense in which I'm using that sort of a reference frame. I mean, I'm not sure. Yeah, as I say, I'm worried that this is just going to become
So I don't
terminology, but
the difference between thinking about an inertial frame as a class of coordinate systems and thinking of it as certainly it's not a coordinate system. You know, you can be in the same, you can re-coordinatize your inertial frame, right? So I'm not thinking of, but I am thinking of them as associated as the class of coordinates adapted to some particular tetrad.
Mm-hmm.
That help?
Okay, yeah, that's helpful. Cool.
Okay, I think we have time for one more question. Noel, I see your hand raised.
Thanks. So this is, I think, related to Neil's question to some extent. Is the notion of a coordinate system here in inertial frame functionalism local or global? I guess in particular, I'm worried about the situation you might have locally isometric spacetimes, but different global properties. And it's not obvious those global properties are going to show up in the local coordinate systems if it's a suitably local notion.
So the definition, right, says that so inertial frames are local, but the structure of inertial frames is a global structure, and topological features are going to show up in the structure of inertial frames, right? So the thought is that whatever plays the role of defining that full class of inertial frames across, to be fair, I'm about to say across the space-time, so you could call me there, but whatever defines the full structure across the whole theoretical space, if you like, is going to be the thing.
Thanks.
Great. All right, I'm going to stop the recording now.